Hello students, welcome to physics class. Today we discuss the dimensions of physical quantities. You know that all the derived quantities can be represented by using the seven fundamental physical quantity. We call these seven fundamental physical quantities as the seven dimensions of physical world. When you are writing a derived physical quantity, this base quantity or these dimensions are right within a square bracket. Once we are writing in a square bracket, it shows that we are deals with the quality of that quantity, not the amount or quantity. There are seven fundamental physical quantities in physics, and these seven fundamental physical quantities are the seven dimensions of the physical world. They are length, and to show that the dimension of length, we represent capital L in a square bracket. Mass, capital M. Time, capital T. Electric current, capital A. Temperature, capital K. Luminous intensity, CD, small letter C and D. And amount of substance, mole. These are the seven dimensions of the physical world. By using these seven dimensions, we can write all other derived physical quantities. Now let us see what is the dimensions of a physical quantity. The dimensions of a physical quantity are the powers to which the fundamental quantities must be raised to represent that quantity completely. The dimensions of a physical quantity are the powers to which the fundamental quantities must be raised to represent that quantity completely. For example, once writing the density, density is a derived physical quantity, and the expression for the density can be write as mass by volume. Mass by volume. Density is equal to mass by volume. And usually for any body, we can write the volume as length into breadth into height. Length into breadth into height. So mass divided by length into breadth into height. You know that length, breadth and height all are actually the length measurement. So now we are representing the density with the fundamental physical quantity or seven dimensions. That is, the dimensions of mass is m. Within a square bracket, we are writing capital M. Now we have the dimension of length, breadth and height. All are length measurement. So length, we are writing capital L. Breadth also a length, capital L. Height is also a length, so capital L. So L into L into L. So L raised to 3. So M by L raised to 3. The dimension of mass divided by dimension of length, power 3. M by L raised to 3. So we can rewrite like this way. M L raised to minus 3. M L raised to minus 3. So that's the dimension of density. The dimension of density is mass M L raised to minus 3. So we can say the dimension of density are 1 in mass. Actually, the power of M is 1. So the dimension of density are 1 in mass, and the power of L is actually minus 3. So minus 3 in length, minus 3 in length, and 0 in time. Actually, to represent the density, we are not using the time. So we can write the power of time is equal to 0, t raised to 0. If you write t raised to 0 here, there is no change for this equation because the power of time in density is actually 0. So 0 in time. That is actually the dimensions of a physical quantity. The dimensions of a physical quantity are the powers to which the fundamental quantities must be raised to represent that quantity completely. Okay. Now, what is the dimensional formula? The dimensional formula is the expression which shows how and which of the fundamental quantities represent the dimensions of a physical quantity is called the dimensional formula of given physical quantity. The dimensional formula of a physical quantity is defined like this way. The expression which shows how and which of the fundamental quantities represent the dimensions of a physical quantity is called the dimensional formula of a given physical quantity. For example, the dimensional formula of volume. The dimensional formula of volume is m raised to 0, L raised to 3, T raised to 0. That is, you know that volume is equal to length into breadth into height. So actually, the dimension of volume is L raised to 3, m raised to 0 and T raised to 0. So that's the dimension formula of volume. M raised to 0, L raised to 3 and T raised to 0. Now let us see what is the dimensional equation. The dimensional equation. The equation obtained by equating a physical quantity with its dimensional formula is called dimensional equation of a given quantity. Here we are writing as a formula, and once we are equating, we are getting an equation. That is, the equation obtained by equating a physical quantity with its dimensional formula is called dimensional equation of given quantity. For example, the dimensional equation of force is equal to ml t raised to minus 2. Or the dimensional equation of pressure. Pressure is equal to m L raised to minus 1 T raised to minus 2. That is the dimensional equation of pressure. Now let us find the dimensional formula of various derived physical quantity. One is area. The first one, area. You know that area is equal to length into breadth. Length into breadth. So length and breadth actually are the length measurement. So we can write the dimension of area is equal to L into L. The length into length, actually that is equal to L raised to 2. L raised to 2. So the dimension of area is L raised to 2. Now second, volume. Volume, length into breadth into height. Volume is equal to length into breadth into height. Actually all these are length measurement. Length, breadth and height are length. So we can write L into L. That's equal to L raised to 3. L raised to 3. Once you are writing the dimension, you should write in a square bracket. Okay. Now the density. An equation for density is mass by volume. Mass by volume. So write the dimension of mass divided by the dimension of volume. The dimension of volume is L raised to 3. We already find what the dimension of volume, that is equal to L raised to 3. So we can simply write divided by L raised to 3 here. So we can rewrite like this way, m L raised to minus 3. m L raised to minus 3. That's the dimension of volume. Okay. Now speed or velocity. If it is speed, you write as distance by time. If it is velocity, we will write as displacement by time. So if it's distance by time, you know distance is actually a length measurement. So length by time. What is the dimension of time? Capital T. That's equal to L T raised to minus 1. L T raised to minus 1. That's the dimension of speed. If it is velocity, again it is displacement by time. Displacement by time. But displacement is also a length measurement. So L by T only. L T raised to minus 1. The speed and velocity have same dimension. L T raised to minus 1. Next quantity, acceleration. Acceleration. An equation, change in velocity by time. Acceleration is equal to change in velocity by time. So change in velocity, or change in velocity having a dimension of L T raised to minus 1. We know that the dimension of velocity or change in velocity is same L T raised to minus 1. Here it is. divided by the dimension of time. The dimension of time, that's equal to L, take this t here, become t raised to minus 2. L t raised to minus 2. The dimension of acceleration is L t raised to minus 2. Now, the dimension of momentum. What is the dimension of momentum? Equation for momentum, mass into velocity. Momentum is equal to mass into velocity. So write the dimension of mass. The dimension of mass divided into dimension of mass into the dimension of velocity. Velocity is L t raised to minus 1. So what is dimension of momentum is m L t raised to minus 1. M L t raised to minus 1. That's the dimension of momentum. Force, mass into acceleration. Force is equal to mass into acceleration. So m, mass, m. Acceleration, we already find what is acceleration, dimension of acceleration. That's equal to L t raised to minus 2. L t raised to minus 2. That is m L t raised to minus 2. M L t raised to minus 2. That is the dimension of force. Now let us see what is the dimension of work. The dimension of work. The dimension of work is equal to an equation for work, force into displacement. Force into displacement. What is force? The dimension of force is this one. M L t raised to minus 2. M L t raised to minus 2 into displacement. Displacement is actually length. So what is the dimension of work? M raised to 1. L into L become L raised to 2. So it become M L raised to 2 T raised to minus 2. That is the dimension of work. Now energy. Energy is nothing but the ability to do work. Or energy is actually the work done. Work done. So the dimension of energy and work are same. The dimension of energy and work are same. M L raised to 2 T raised to minus 2. Because the energy is nothing but work done is known as what? Energy. Now, power. The next quantity is power. An equation for power is equal to work done by time. Power is equal to work done by time. What is the dimension of work? M L raised to 2 T raised to minus 2 divided by time. Time is equal to T. The dimension of time is T. So what is the dimension of power? Power is equal to M L raised to 2 T raised to minus 3. T raised to minus 3. That's the expression or dimensional formula of power. Now pressure. Pressure. Equation for pressure is equal to force by area. What is the dimension of force? It is dimension of force is M L T raised to minus 2 divided by the dimension of area. What is dimension of area? L raised to 2. So rearrange, we get M L raised to 2 and L raised to 1 is here. So it becomes L raised to minus 1. M L raised to minus 1. T raised to minus 2. L raised to minus 1. T raised to minus 2. That is the dimension of pressure. The physical quantities are sometimes maybe a variable or maybe a constant. So here a physical quantity having a variable value with a dimension and having a dimension can be called as dimensional variable. The physical quantity which possess dimensions but have a variable value are known as variable or dimensional variable. They are known as dimensional variable. Example, area, volume, velocity, all are dimensional variable. All these physical quantity can have different value, so they are variable, but they have a dimension. So they are known as dimensional variable. Now, dimensionless variable. The physical quantities which have no dimensions but have a variable value are known as dimensional variable. For example, angle. The angle usually we are writing as angle is equal to, for angle is equal to arc by radius. If you are writing the angle is equal to arc by radius. Arc and radius are length measurement. So the angle having a dimension, that is length by length. So 1. So better you can say it's dimensionless. Angle is dimensionless. Specific gravity. What is specific gravity? It is relative density. Density of the substance by density of water. So both density, dimensions getting cancelled. So specific gravity or relative density have no dimension. Strain, change in quantity by original quantity. Change in dimension by original dimension. So strain have no dimensions. So they are variable without dimension. Can be called as dimensionless variable. Now, dimensional constant. Some physical quantities may be constant. The physical quantity which possess dimension and have a constant value are known as dimensional constant. Dimensional constant. Example, gravitational constant. In Newton's law of gravitation, we have a gravitational constant capital G, and that gravitational constant is a dimensional constant. It have a dimension. We will find it later. And Planck's constant, small letter h, it have some dimension. So having a constant value with dimension are known as dimensional constant. And dimensionless constant means the constant physical quantity have no dimension are called dimensionless constant. The constant quantity having no dimension are called dimensionless constant. Example, pi, that is 3.14 exponential function are constant, but that function have no dimensions. They are known as what? Dimensional or dimensionless constant. They are known as dimensionless constants. That's all today. Thank you.